Okay, so we're going to be doing learning target 7 and learning target 8. Explain operations on irrational and rational numbers and solve equations using square roots. Okay, so let's first start with the term or the definition for the square of a number. The square of a number is the product or multiplication of a number in itself. So we all know that 3 squared, we can write this as 3 times 3. The multiplication of itself. We write it like this with this 2 on top because it's a lot neater and it takes up less space than 3 times 3. So our example, x squared has my x with my 2 just like my 3 with my 2, and this one is just x times x. So if it was 5 squared, it would be 5 times 5. The square root of a number. It is the opposite of squaring a number. So when we solve equations, when you do the opposite thing, if it's squared, you do the square root. If it's a square root, you square it. So every positive number has 2 square roots, so for this example. So the reason that we get this, the way that we can get this number, so this is asking what times itself, so like x times x will give me 36. What is this x? That's 6. That's what this is, all this is asking. So the way that we can find this is we can see that 6 times 6 gives me 36, and that's why this part is positive. But isn't negative 6 times negative 6 also a positive 36? So we have 6 squared is 36, and negative 6 squared is 36. So that's why when we square root things, we always say that it has a positive and a negative answer because of this right here. So, in like a lot of problems, you'll find things like this. Find the side of a square whose area is 81 inches squared. So if this is my square, each square has a side x, right? And since it's a square, they're all the same side. The area of a square is base times height, or side times side. And here, in this case, it's side times side. And we know that the area is 81. Well, we can also write this as x squared, right? Because x times x is x squared. So here's a one-step equation. When I have a squared, I undo or do the opposite of a square by square rooting it. So I take the square root of both sides, because what I do on the one, I have to do on the other. The square root of x squared is just going to give me x, and I'm going to show you why over here. Just say I have the square root of 4 squared. According to PEMDAS, I need to do exponents first because I don't have parentheses. 4 squared is going to give me 16. The square root of 16 is just going to give me a plus or minus 4, which is what I had up here. So that's how we can just write x, and then equals our plus or minus. So the square root of 81, what's the square root of 81? We know that 9 times 9 gives me 81, but it's going to be plus or minus. In this problem, though, since it's area, you can't have a negative area. In this problem, my x would be 9 inches because we can't have a negative area. But if you're just solving an equation without words, it would be plus or minus 9. This is going to give you your 4. Just 9 is going to give you your 3.5. So here, area equals 5. Again, we have x, 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 x. My area is going to be x times x equals 5. X squared equals 5. So now I'm going to take the square root of both sides. The square root of x squared is just going to give me x. I know that from over here. There is no thing that is going to give me 5. 2 times 2 is 4. 3 times 3 is 9. Nothing's going to give me 5. So I'm going to leave this as the positive or negative square root of 5. You can't really see that. But so this is going to be my answer. So, but if we wanted to, I know right from here that 2 squared is going to give me 4. 3 squared is going to give me 9, right? I did that right here. And I want 5. My answer is going to be 5. So that's going to be somewhere in between here, right? 5 is in there. So my answer is going to be somewhere between 2 and 3. So it's going to be 2 point something, blah, 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 blah. Or we're just going to leave my answer as this because I can't solve that nicely. Okay, so we were just talking about irrational and rational numbers, and you might have heard about these, you might have not. An irrational number would have been like the square root of 5, and a rational number would have been the square root of 81. We can't do the square root of 5. It's an irrational number. An irrational number is a number that cannot be expressed as the ratio of 2 integers, or it cannot be expressed as a fraction. In decimal form, it has an infinite number of digits, so that means it goes on forever and ever and ever and ever. And it doesn't show a repeating pattern. So that means it's not like 0.66666666, or it's not 2.1818181818. It's like 2.1653, and it just goes on forever with no pattern. A rational number can be written as a ratio or as a fraction of two integers, right? Like this gives me plus or minus 9, and 9 can be written as a fraction, right? It can also be written as 81 divided by 2. Or 18 divided by 2. I'm looking at this 81. An integer is any one of the numbers, so it's all of your counting numbers, negative, positive, and 0. Whole numbers are just your positive numbers including your 0, and a natural number is just your positive numbers not including 0. So if we look over here, it splits it up for you. An irrational number would be like the square root of -7, just like the square root of -5. It's not going to work. Pi is your most common one, right? 3.14, and it goes on forever and ever and ever and ever. If we look over here, this shows us our little subsets. So these are all, everything in here is rational numbers. But these out here are not integers, and everything outside of this is not a whole number, and everything outside of that is not a natural. Blah, blah, blah. So if you look at our rational numbers, here this is written as a ratio. That's why it's a rational number. And when you find it in decimal form, it's 0.66666, which is a pattern or repeating. 2.8, this is still a decimal, but it ends. It doesn't go on forever and ever and ever. So that's why it is considered a rational number. So before class, I want you to add another number to each category. So you have to add an irrational number, a rational, an integer, a whole, and a natural to in here. You're adding one for all of them, and then we're going to go over that tomorrow.